Hello everyone, and welcome to our presentation about the physics of weightlifting. Today, we'll explore how physical principles influence lifting mechanics, focusing on the three key lifts: the deadlift, squat, and the bench press.
Our project is aiming to analyze variations in lifting technique and their impact on force distribution, torque, and stability. We're going to demonstrate how physics can guide you to a safer and more effective weightlifting practice by delving a little bit more into these concepts.
Weightlifting is not just a physical activity, it's a complex biomechanical challenge where physics plays a central role.
By understanding these principles behind weightlifting, we can help lifters reduce their risk of injury and optimize performance, while also highlighting the practical applications of physics concepts like torque and energy in day-to-day life.
In this project, we're mainly examining the lifting mechanics for individuals of varying heights and body proportions across three different lifts, as we mentioned.
Some key concepts that we're going to be covering in this presentation are torque, rotational force, and how much strain a joint experiences during a lift. These were the main things that we found to be significant during our analysis, and we're primarily focusing this project on why taller individuals have a little bit more difficulty lifting higher weights. So with regards to torque, it is more difficult for taller individuals to lift more, as just based on their body proportions, the weight is placed further from the axis of rotation. For example, on a bench press, the axis of rotation is going to be your shoulder/rotator cuff. Due to taller individuals having longer limbs, the distance between the barbell during a bench press and this axis of rotation is going to be larger. As we know from the torque equation, torque is derived from the distance to the axis of rotation and the perpendicular force coming from the barbell and gravity in this scenario. Since this distance to the axis of rotation is larger, a taller individual is going to be experiencing more torque from the barbell acting on their internal joints. This means that they're going to have to generate more internal torque, primarily from their smaller stabilizing muscles and joints in order to counteract this, which can make it more difficult to lift heavier weights.
Furthermore, we're also going to look into the energy expenditure. Taller individuals tend to have longer arms if your body proportions are standard. So that means that the actual distance from hitting your chest with a barbell to a fully extended arm, that mass has to travel farther distance than someone who has shorter arms. So someone who has shorter arms, let's say they have half the length of a taller person's arm, that's unrealistic, but that means they would have to only move at half the distance. And just by looking at the gravitational potential energy of that, the distance and that change in height is going to be a significant change in that potential energy.
In order to mathematically prove that what we're talking about is real, we calculated the difference in torques for shorter and taller individuals in a hypothetical situation. So, as showing now, we calculated the increase in energy and torque expenditure for an individual with 1 inch longer arms in the bench press relative to someone with 1 inch shorter arms. So, an overall difference of 1 inch. Through our calculations, we were able to determine that this 1 inch difference in limb length, while seeming insignificant, directly corresponded to around a 3.3% increase in energy expenditure and general difficulty for the taller individual during the bench press. This is why many bodybuilders that we found in a scholarly article were much shorter than on average male in the US. This is because when it comes to gaining muscle and lifting much heavier weights, it's much easier to put on mass when there's less torque and force acting on your muscles and internal joints as you go up in weight. In addition to this, we also found a scholarly article citing how taller individuals performed worse at deadlifts compared to individuals with shorter trunks and shorter limb proportions in general, which support our findings. Now, the reason that our findings on the bench press are applicable to other lifts that we've analyzed, such as the squat and deadlift, is because similar to the bench press, a taller individual with longer limbs is going to see a larger distance from the barbell to the axis of rotation during these lifts. This means that they're going to be experiencing more torque from the barbell acting on them and will have to expend the same amount of energy to lift the same weight. This makes our findings very applicable to a wide variety of lifts in the gym.
The reason this is such an important topic is because specifically in weightlifting, you can be very prone to injury, especially in taller individuals, because of that change in distance and change in energy that's necessary, that change in torque compared to a small individual. You're going to have more forces acting on different parts of your body depending on the lift. If the distance away from your chest in a bench press, for example, there's going to be more pressure in your shoulder compared to someone who's closer to that axis of rotation. Making sure that your form is proper and limiting that unnecessary torque and unnecessary energy expenditure is going to keep them safe.
Now, a major technical factor we found in our research regarding safety and technique on these lifts was maintaining a neutral spine. As you can see, an exaggeration of a perfectly straight spine during an exercise, such as the squat, can place excess pressure on the spine. In addition to this, it'll force a small component of the force generated to point in the horizontal axis, which is not optimal since your muscles are best at exerting force linearly, not in multiple directions at once. By taking these physics concepts and applying them to your weightlifting technique, you'll be able to see noticeable improvement in not only your strength, but safety as well.
Physics is everywhere, including the gym. By understanding these principles, lifters can enhance their performance and safety by managing their expectations and goals in the gym, making science a valuable tool for strength training. Thank you very much.
Thank you.